chapter. So we're going to have our chapter test next week. Woo! Okay, so I don't remember exactly what day I put it on.
Can we have a review day on Monday, because I'm not going to remember all this stuff.
Yeah.
This has been a hard, like, not as bad as chapter 6, but this has been a hard week.
This weekend.
All right, so here's how next week is going to go. So review on Monday, review sheet, and then quiz over the last couple sections on Tuesday. Wednesday I won't see you because we have an early out, and it's all the afternoon classes that are meeting in the morning because it's a teacher and service thing.
It's a half day.
Yes. Okay, then on Thursday we'll review. Friday's going to be test. So I'll give you this review packet on Tuesday.
What?
He won't be here.
Won't be here, why not?
States.
Oh, that's right.
Oh.
Yes! The week I'm gone, so I'm going to have to take it for 2 weeks.
That's what we thought about you.
I got money in that's great, but I didn't go back.
All right, so here we go. Let's finish this last section. Finish this last section. Okay, waiting for you. Okay, so today we're solving radical equations and inequalities, meaning if we have a radical, it could be a square root or third root or whatever, and there's an x under there, and we have an equal sign somewhere, we're going to figure out what that x can be. Okay, this is obviously a really simplified version, but we're going to figure out what x can be, okay? So our first thing to do when we're doing this type of thing, when we're solving an equation, x under a box, is we're going to isolate the root, the box, one side of the equation.
It's going to be really easy today.
Yeah. Step number 2 is to raise each side of the equation to the power equal to the index of the radical, to eliminate the radical. In other words, if it's a square root, square both sides. If it's a cube root, cube both sides. If it's a fourth root, take each side to the fourth power. You get the idea, right? Alright, then we're going to just solve the results of the equation. I have a little note there. It says, sometimes in solving a radical equation, you may get a result that does not satisfy the original equation. You may do all the steps right and come up with x equals something, but when you plug it back in, it won't work. Okay, so you always have to check this, because even if you do all the steps right, if you plug it back in, sometimes it won't work. This is called an extraneous solution. Which I don't know what it's about.
Get it English, please.
Extraneous.
That means that it's just
In other words, you do all the steps right, Matt. You do all the steps right, come up with x equals something, but when you plug in that number up at the top, it won't come out right.
Is it just no solution? It doesn't come out.
You would just say extraneous.
You have to write out extraneous.
just right to the x.
Just raise x. You take the x.
It's pretty right here. Extraneous.
It's all here.
Guys. Just
Okay, so let's look at number 1 for this first. It's a solving this equation and to check for extraneous solutions. Our first step is to get the box all by itself on one side. What do we have to move to get the box by itself?
Negative 4.
Okay, right back and forth, get 4 over here, get the box by itself. Alright, what's 7 minus 4? 3. Alright, now we have to get rid of the box. Okay, we gotta get rid of that. Yep, so we're gonna square both sides. Square both sides.
Just plug
We got
it
3 is a
in.
9. We got x plus 2. Subtract 2. X is 7. Yes!
How proud are you?
Is that it for today?
Well,
No.
okay, now, you are not done with this problem because you also have to check for extraneous solution. You have to make sure it works if you plug it back in. Alright, does it work? 7 plus 2, 9, 49 is 3, 3 plus 4 is 7.
But the next one's extraneous.
Maybe. Okay, so now with this one. With this one, you have 2 radicals, right? You have 2 boxes. Is there a way that we can isolate so that we have a box on one side and a box on the other?
Square out everything.
So in this case, we're going to have to square both sides.
Which is
Okay, so this one is easy on the left side because that's just left with x minus 12. But over here, we have to FOIL. Why?
There's two different things.
Yeah, because we're adding or subtracting. Okay? So this is saying 2 minus the square root of x times 2 minus the square root of x. Alright, so if we FOIL, first things first, we get 4. Then I always do inside here. And then outside. And then what's a negative square root of x times a negative square root of x? Plus x. Yep. So these two go together to give me negative 4x plus x. Okay, so we still challenge. Okay? You guys are wasting time. I'm going to give you homework and I can make it even longer if you want. Two.
I got you.
Are you going to the game tonight?
I can't.
Oh, why not?
Alright, let's look at this problem. So, we still have a square root, okay? In order to get rid of that, we still have to get it by itself. So we need to move everything else away so that the square root box is still by itself. So I can square it in to get rid of it.
Exactly.
Minus 4 minus x.
Yep, minus 4, minus x. Okay, so this x is gone. So this would be negative 16. So then what do we do?
X equals 16 divided by negative. Yeah,
Wait, whatever happened to the...
Bummer.
Bye-bye. Oh, I get it.
So this would be 4 equals square root of x, right? Now we can square. So 16 equals x. Now, we have to check it. So the we're going to plug it back up here. What does it? Well, let's see. So we have the square root of 16 minus 12, 2 minus square root of 16. So that'd be 2 minus 4, negative 2. We know this is a negative. Definitely a square root won't equal a negative. So this would be extremes.
Okay, how do you okay? So you're plugging 16 for x, correct?
Yep, at the very, very top. If we plug in 16, 16 minus 12 gets us 4. And the square root of 4 is 2. But that does not equal negative 2. 2 does not equal negative 2. It's
So you just ran x radius and that's you actually have to check your work.
It's half the time.
Do you have to do all of that?
Yes. There's
You
no
have to.
Yeah. How else do you think we can do it?
Just plug it in.
Just plug it in.
Not for that one, but for
I don't understand.
C. Do C.
Do you see? What are you going to plug in?
38. Do math.
Where are you going down to 38?
Minus 2 would be 66 minus 1 is 1.
Okay. Well, let's see if we do the problem we come up with that. Because sometimes, yeah, you can see the answer, but sometimes when you look at the problem, it won't come out that way. Like this, like it's going to be an extreme use. So yeah, you still have to do the problem.
That's
Does
38.
that make sense? Is it 38? I
It's
don't know. Let's try it. So we have to get the box by itself. We're going to square both sides to get rid of the box. So in this case, it is 38. Does it work if we plug it in?
Yes.
Alright, so we're going to put it up there.
Can't we just do it?
No, I want to see more. Alright, do you want to do the last one or do you want to move on?
No, you know what you should have? You should have this do the last fire.
No, we should come on.
Alright, let's move on.
It's up to you guys.
It's not gonna matter because I gotta go to class. Like, I need to make sure I know.
Yeah, but we don't have to go to class. We don't know our thing about it.
Go with the guns, get me some students. We'll always do this. Hold on. I don't want to keep
I got it.
But I suppose so. I already went through all this today.
Yep, we're over all of this. Alright, do you want to do the square root? What do we do? Square. Alright, so to undo a cube root, you're going to raise the expression to the third power, right?
Cube.
You're going to cube it. Because if you got a cube root and you cube it, then they cancel out. So let's do undo it an nth. But you're going to raise it to the nth power, whatever that nth is. Okay? So what they've done now is we're going to work with it just like we did before. But instead of having boxes, they're using the fractions. That's okay. That's fine. So again, we're going to get it so that we have whatever is to that fractional exponent by itself. That's the first one. How are we going to do that?
Add 4.
Add 4 first, yep. Okay, then what?
This is the kind of math I like. It does not.
By 2.
We divide everything by 2.
Wow. Okay, so remember this means third root, right? So you're going to do just everything to the third power. Okay, I know that's 8. Now what? The next is going to be 6.
Yes!
Now,
Look at that.
is it extremely loose?
I hope not.
Okay, well, let's see. 6 times 11 over 6, the 6's cancel. What's 11 minus 3? 8. The third root of 8 is 2. 2 times 2 is 4. Minus 4 doesn't give 0. Yeah, it checks out.
It's all good. Seal approval.
Yep.
Okay, let's go to the next section.
Yep.
So I know what to do before I leave.
You guys want to do more like this? It's the same idea as what we just did in the front. The only thing that changes is instead of squaring, just take it to like the third root because it's a fraction of 3. Got this. Got it? Sure?
Is there ever going to be like any normal? Oh, wait. So instead of doing 1/3, you just multiply it with 2.
Ooh.
Got it.
We'll always do 1/3 or 1. Wait, let's see what you get in the next round.
In this part, I don't think so.
Okay.
I don't think that's
That's a
But
lot.
we'll get there.
That is a lot.
Okay, last thing we're talking about is solving radical inequalities. Okay, remember inequalities are like the less than and greater than and all those things. Okay, so first, you're ready. First, we said if the index of the root is even, so we got a square root or a fourth root or whatever, then we're supposed to identify the value for the variable for which the radicand is non-negative, because we don't want to be working with imaginary numbers. We can't have any i's. So we don't want any negatives under a square root box or a fourth root box or 6 root box. Okay? Then we just solve it algebraically. We solve it exactly like we did before. And then again, we need to test or check to make sure that we don't have an extraneous solution. Just a couple notes there. Remember to flip the symbol when we do what? Multiply or divide by a negative.
Oh. Only by negative, right?
Right.
What if the negatives are going to be on the other side?
Negative's already on the other side. If you're not multiplying or dividing by that number,
Well, say if it's say on the first one, instead of an 8, it's a negative 8.
are you going to multiply or divide by that negative 8?
Well, you divide 3 on both sides. Would you still switch it? Positive 3. No. Well, let's try it. I got you.
And also, since the principal square root, or fourth root or whatever, is ever negative, inequalities that simplify to this form, where we're saying whatever is in the square root box is less than or equal to a negative, then we know that there is no solution, because you can't have a square root equal to a negative, nor can you have a square root less than or equal to a negative, because it just
There's going to be one of those on the assignments. How come you don't have any of those on here?
The square root equal to negative, that's possible. It's a square root of 4, so it would be negative.
It's too different.
Oh, I don't remember that.
the square root, you can't take the square root and use the negatives in the other. We don't want to stick with all right, let's try this one. Let's try this one. Okay, first what we're going to do is we're going to take whatever is underneath the square root box, and we have to set it greater than or equal to 0. Remember, because we cannot have an imaginary, because if it's a negative, then it's imaginary, we can't have that. Okay, so we solve. So x has to be greater than or equal to 2. Nope, that's not our answer. So this is just our first step. Since we cannot have an I, we can't have a negative of the square root box, we're saying x has to be greater than or equal to 2, because if it's anything that's less than 2, then we're going to get an I. Okay? Alright, so now let's work the real problem, the whole thing here.
Wait, that's what?
Okay, somebody help explain that, what we just did.
Not it.
Explain those laws.
We just set it to 0. Greater than or equal to 0.
Why?
Okay, why do we set it greater than or equal to 0? Make sure that
It's also some negative.
right. So if it's negative, then we have an I. We can't have an I. Okay?
But I hate eyes.
All right, let's try this. So we have the whole problem.
What
That was
Not a very nice person.
the whole problem. Stay with me, please. Okay, so then we've got, what do we do now? Got the box by itself. Square everything. Yep.
Is it a worksheet or
It's
It's in the what?
Oh, man.
X is going to be less than or equal to 7. Okay, now we have to be careful because sometimes in your answer you don't have to include this one. Okay, here's why. So in this case, you don't have to write this down on your paper or your answers, but I think the visuals kind of next year. Okay, so we've got 2 and we've got 7. Okay, this tells us that x has to be less than 7.
You have to do the line thing or not?
Okay, so we're going to shade that way, right? But this one tells us, well, if x is anything less than 2, it's going to be imaginary, which can't happen. So we can only go to 2. We can't go any farther because then we'll have imaginary. So in this case, we're including both of these in our answer. So our answer is going to say that x has to be greater than or equal to 2, but less than or equal to 7. Does this make sense? If, there's only a second.
No.
Oh, yes, we should check. 7, 35 minus 10 is 25, square root of 25 is 5, 3 plus 5 is 8. One thing, if this was a, stay with me. I'm just changing this for a second, okay? Let's pretend that this was a greater than or equal to 7. That means that we would shade this way. You would have to include the 2 in that case.
You have to shade. You have to do the graphic.
You have to do the graph, but it's easy to see if you include the other thing. Does this make sense of when we have to include this and when we don't? Do you want to do one more example, or do you feel okay?
I think that's what you do.
Sure?
I have a feeling that this is going to be hard.
It's not.
Can I have things over paper?
Yeah.